Our initial aim was to implement a remote diagnostic solution for our products, limit the amount of service time it was costing us to go and visit our customers, but then it extended fairly soon into something much wider, which was an opportunity to move up the data quality ladder.
Data is at the heart of everything that we do. We chose Azure for the ecosystem that it brings and the number of different applications that you can use. We created a cloud-based solution that allows our customers to connect and track utilisation and health of their instruments. Material analysis is what Malvern Panalytical is all about.
I'm Mark Nichols and I'm the data science leader here at Malvern Panalytical. We're working on sizing how much data we'll be anticipating, testing the models and doing all the experimentation work, which we do within the Azure ML framework. Some of the things that we really like about Azure are the fact that we can spin up on-demand compute clusters and virtual machines to our specification really quickly. That's something that the data scientists really love. The digital initiative really is about how we can connect instruments that are measuring those kind of properties to the cloud.
Historically, we've done remote diagnostics in the past, and it's very, very difficult because the infrastructure is complex, it's very bespoke and changes around the world. If you can eliminate some of that and remove some of those or simplify some of those layers down, then suddenly the connectivity becomes much more viable option.
Smart Manager is going to be the core component of the whole digital vision really, because it's going to connect our instruments to the cloud.
And that's what Azure did for us. It made the connectivity possible and scalable.
Edge methods have given us the ability to have a bit of a head start in terms of building the blocks on top of the Azure platform that we need, enabling us initially to just gain health information about the state of an instrument and other telemetry perhaps from the instrument, so that down the road we could do predictive maintenance, help schedule in a customer service visit rather than the instrument going down and the customer having to deal with downtime of the instrument.
We're using various open source tools, obviously from Python for data science development through to logging applications like SEQ, Terraform for infrastructure as code solutions. So we're using them in conjunction with the standard built-in Microsoft Azure building bricks. The fact that those tools just work and they integrate with our existing tools makes the whole opportunity much more flexible, much more integrated, and speeds up the development process. We went to Azure DevOps as early as we could, and that allowed us to build pipelines, automate the testing and integrate it into the build process.
Key learnings are being aware of the development environment and how it varies from traditional development environments and what the additional constraints and threats are, and making sure that you've got the capacity to deal with all of the sorts of problems that you face, the massive amounts of data that are involved in these kind of things. I can't imagine running a project of this scale without those kind of tools and without that kind of flexibility, so it's great.